Okay, this is the Pre-Algebra Unit 4 test review over exponents and roots. So this is kind of a long study guide. So what I decided to do is make you guys a video so you can grade this over the weekend. Make sure you're understanding all the material. And then on Monday before our test, if you guys still have some burning questions you want to ask, you guys can bring in those questions. So the first section is telling us it's about exponents. So we have to write these repeated multiplication problems in exponential form. Right here, write that in exponential form. So our first one is 5 times 5 times 5 times 5 times 5. Now when we're writing in exponential form, we use whatever number we're using in repeated multiplication, so we know our base is 5, and then the exponent is how many times we are multiplying it. So in this case, it should be just 5 to the 5th is our final answer there. For number 2, same type of thing, except now we're just using a variable, which doesn't change what we do. So k is our base, and 5, again, is our exponent. Now, if we look at number 3, it's a little bit different since it's 2x times 2x, but when two things are next to each other, a number and a variable, it's just like saying 2 times x. So all of these are being multiplied together. So there are 1, 2, 3, 4, 5, 6 2s, so it should be 2 to the 6th times x to the 6th, because there's also 6 x's, or you guys could put 2x in parentheses to the 6th. Since both those numbers are in parentheses, that 6 would be applied to both. So either one of these would be an acceptable answer. Now number 4 has two different numbers, so we're doing the same thing. It'd be 8 to the 3rd times 7 to the 1, 2, 3, 7 to the 5th. That is our final answer there. So that's all you're doing for writing numbers in exponential form. The next section we're asked to evaluate, and we need to show all of our work, and sometimes we're not so good at that, so we need to make sure we show all of our work. So this first one is negative 3 in parentheses to the 3rd, so it's just like saying negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is a positive 9 times negative 3 is a negative 27. So negative 27 is our final answer there. Number 6, 278 to the 0 power. Anything to the 0 power is always 1. So we know that one's just 1. There's really no work we can show there. For number 7, 10 to the 6th is 1 million. But we have to remember this negative sign is on the outside of our parentheses. So we apply that afterward. So it should be negative 1 million for that answer. Go back up to 8. We have 6 minus 8 in parentheses to the negative 4th power. So first we evaluate what's inside those parentheses. 6 minus 8, we remember our integer rules. It should be a negative 2. That is still in parentheses to the negative 4th. Now when we have negative exponents, remember we want to use the inverse. So that should end up being 1 over negative 2 to the 4th power. So now we've made that exponent positive by using the inverse. And remember that negative 2 still is in parentheses. So this is saying 1 over negative 2 times negative 2 times negative 2 times negative 2. Now there's four negative numbers we're multiplying, so our answer is going to end up being a positive number. And it ends up being 1 over 16. 2 times 2 times 2 times 2 is 16. So 1 over 16. For number 9, it's a little bit longer, a different expression, so we're going to take it one step at a time with each of these terms. So 9 to the negative 1st, I'm going to just write that as 1/9 plus, now this has, they're in parentheses 12 minus 9, so we have to do that first. So it's going to be 3 to the negative 2, so it's just 1/9 plus 1 over 3 squared, which is the same as 1/9 plus 1/9. Since we have common denominators there, we can just add those numerators, keep the denominator. So ends up being 2/9. That's our final answer for that one. Number 10, a little bit longer. So 11 to the 0 power. And remember, anything to the 0 power is 1 times something with, these are negative exponents. We're going to take care of those. 1 over 6 squared times 1 over 5 squared. So this is 1 times 1/36 times 1/25. This is just like 1 over 1. So we're going to multiply our numerators across, which is 1. Multiply 1 times 36 times 25. That should be 900. You should have 1/900th for your final answer, 1 over 900. Our next section deals with the properties of exponents. Remember, we made a foldable on this, did a couple sets of notes on this. So what we're wanting to do is write the product or quotient as 1 power. We have to make sure we're combining our exponents using the properties that we've learned. So in this case, we're multiplying numbers with the same base. So what we do with our exponents is we add them. So 5 to the negative 2 times 5 to the 8. We add negative 2 plus 8, which ends up to be 6. So that is our new exponent. So it should be 5 to the 6th power is our final answer there. Remember, we're not evaluating it. We're just writing it as 1 power. Now number 12 is x to the 6th times x. Now since this x here doesn't have an exponent written on it, we already know it automatically has to be a 1. Okay, x to the first power is the same as just x. So again, we have the same bases, so we add our exponent, 6 plus 1. So our final answer written as 1 power should be x to the 7th power. Now here on 13, we have 2 to the 3rd over 4 to the 8th. Now these don't have the same base, and remember, we wrote same base on our foldables in all capital letters and underlined them and made sure we paid attention to that. We have to have the same base to be able to use these properties. So we cannot combine these. So it's a little bit of a trick question. Cannot combine. Number 14, we have 6 to the 13th power divided by 6 to the 5th power. Now when we're dividing with the same base, we subtract our exponent. So it's 13 minus 5, which ends up to be 8. So our final answer should be 6 to the 8th power. Number 15, we are raising a power to a power. In this case, we multiply our exponents. So negative 3 times 5, negative 15. So our answer should be 7 to the negative 15th power. Again, for number 16, we're raising a power to a power. So we keep our same base and do 3 times 4, which is 12. So our answer should be 8 to the 12th. Now we have a few different properties we have to remember. It's multiplying numbers with the same base, we add our exponents. Dividing numbers with the same base, we subtract our exponents, and raising a power to a power when those two are next to each other, like in 15 and 16, we multiply those two numbers together. Okay, next section, moving right along. We get to scientific notation. Now we want to write each one of these in standard notation. We need to show our swoops to show work. A lot of you guys always ask me, how do I show work on this? Well, we show our swoops, and that's how I know you guys know what to do on this. So our negative exponents means we are swooping our decimal to the left, making our number smaller, and we are swooping that 5 times. Do once, twice, 3, 4, 5. We fill in all of these blanks with zeros. So our final answer should be 0.0000275. 275. Okay. Number 18, we have a positive exponent, so that means we swoop our decimal to the right. And this is 3 times. 1, 2, 3. Fill in those blanks with circles, with zeros, excuse me, so it should be 6,500 is our final answer there. Number 19, again another positive exponent, so we're swooping it to the right, 9.04. Swoop that 7 times. 1, 2, 3, 4, 5, 6, 7. Fill in these blanks with zeros. So our answer is 90,400,000. Big number. Now this next one is a negative exponent, so we're swooping it to the left, 0.25. Now we are swooping that decimal 8 times, so it's going to be a really small number. 1, 2, 3, 4, 5, 6, 7, 8. Again, fill in these blanks with zeros. It should be 6, 7 zeros. 1, 2, 5. So there should be 7 zeros there, and then your 1, 2, 5. Okay. Next section. Now we're switching from standard notation to scientific notation. You guys are really good at these. So we're writing each one in scientific notation. Again, we're showing our swoops, and that's how I'm going to see your work on your test. So we want our number, our first number in scientific notation, to always be greater than or equal to 1, but less than 10. That's the first step. So I want my decimal, in this case, to be between my 5 and my 8. So then it's going to be 5.8 is my first number. It's always times 10 to some power, and the power is how many times we swoop our decimal. 1, 2, 3, 4, 6. In this case, it's a negative 6 because we are making this really small number into a bigger number. So if I took this 5.8 times 10 to the negative 6 and wrote that into standard form, I'd have to swoop my decimal 6 times to the left, which is what I'd want to do to match my beginning number. So that's how you guys can check to make sure you know when your exponent should be positive or negative. For 22, I want my decimal between the 8 and the 9, so it should be 8.93 times 10 to some power. So my decimal right now is at the end. So I'm going to count how many times I have to swoop it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 8.93 times 10 to the 11th power. For 23, I want my number, or my exponent, my decimal to be between my 4 and my 1. So I remember I have to use all of my digits. So it's 4.115 times 10. I have to figure out how many times I have to swoop my decimal. 1, 2, 3, 4, 5, 6, 7 times. So it'll be 10 to the 7th. And last but not least in this section, I want my number to be 2.68 times 10. In this case, again, my exponent is going to be negative. So 1, 2, 3, 4. 10 to the negative 4th should be my final answer there. So those were just standard scientific notation, practicing switching between those two forms. This next section is finding squares and square roots. Now we used our reference sheet to do our homework a couple of the nights. This we can't use our reference sheet on, so I suggest you guys practice doing this without a reference sheet. It says to find the two squares, remember that, so we need that positive negative sign. So for 9, these are all 25 through 30, they're all perfect squares. So finding the two square roots of 9, square root of 9, positive and negative 3. For 26, the two roots for 225 are positive and negative 15. 27, positive and negative 12. 28, positive and negative 14. 64, positive negative 8. And last but not least, 256, positive and negative 16. Now we still have a couple more pages for our review, but this video only lets me do for 15 minutes, so I'm going to end it here. I'm going to call this part 1. Hopefully you guys did well on this, and then watch the second video to see how you did on part 2.